Hello guys, we're going to solve this question today. The question states that the pseudocode for the function fun is given below. Yeah, this function is given to us. Okay. What are they asking from us? This is an array and its indexes are from 0 till 29. So 0 based indexing is being used. Okay. And it stores 30 distinct integers. Okay. Obviously 0 till 29 from 0 based indexing. So 1 till 29 is going to become 29 number of indexes and plus 0 as another index, totaling to 30 distinct integers, right? And it is given that this particular array is in descending order, right? I do hope that you must remember the meaning of descending order. Descending order basically means that the elements are the value of the elements are decreasing as the indexes are increased, right? So suppose that this is a kind of array that you have. The indexes are going to be 0, 1, 2, right? So as indexes are increasing from 0 till 2, the values of the array are basically decreasing, right? So this is what decreasing order basically means, right? The number of swaps operations that will be performed, okay, if the function fun is called with this this array of 30 elements as argument is. So it is basically asking from us that how many times this swap operation is going to be performed, right? If this particular array is fed into your function. First of all, let me make this very clear that this is not a valid C code, because C syntax does not allow this kind of representation of an array inside of a function definition, right? If you were to supply this, it's going to lead to a compiler error. So obviously this is wrong, but because it is a pseudocode and this thing expresses the intent of our code very clearly, so it is allowed. Okay, pseudo basically means that it reflects that kind of code which is not compiler oriented but oriented towards expressing ideas, right? So that part is very clear. So this particular array when fed over here is going to how many times swap is basically being called is something that we have to tell, right? So first of all, in every single function or every single kind of question, normally the fundamental variables that are basically used inside of the question must be semantically very clear to you, because if you don't have a semantically clear definition, a distinct kind of definition, the concept is hazy in your mind, then you are not going to be able to construct complex ideas in your mind, right? So what does this n over here represents? Right, so from 0 till 29, right, this similar kind of pattern is present over here, right? So if we were to match these patterns, then correspondence by corresponding every single term, this last 29 corresponds to n minus 1, right? So if n minus 1 is basically equal to 29, what does n equals? N equals your 30, and 30 is nothing but the size of our array, right? So this basically gives us, for this kind of pattern that is being presented, it's a very simple straightforward reference that referencing that we are doing with this representation and the kind of array we are given, right? So we can directly state that the semantic meaning of this n over here is basically giving the size of our array that is fed to fun, right? This is very it must be very clear to you, right? Once that part is very clear, just remove this. Now this whole thing has to be analyzed, but see, this swap has over it, right, has over it 3 control oriented instructions, right, statements. So these 3 control oriented statements, 2 of them are loops, right? It is nested loops, 2 of them are loops, right? And their loops have variables that are varying, right? And their variation is causing the loop to iterate, right? So with these distinct values being varied, every single collection, valid collection, is going to be fed into this if condition, and then only those if conditions in which this particular condition is met would this swap operation be performed. There is restriction on this, right? So first of all, I will give you construction of understanding from the total number of variations in which these loop variables are going to come up, that are going to be fed into this if condition, right? That part I'm going to make very clear to you. But obviously I'm not going to go directly and I mean, if there is any kind of battle now, if you have played any kind of games, you don't directly go into enemy fire, right? You don't directly go into and attack the question. You basically pick up a plan, pick up a strategy, and then attack, right? In the same way, in this question, you obviously from a completely mathematical point of view, if you follow, a kind of representation of this kind of array is very easy. Directly imagine, basically equate the reverse indexes as your values, right? And that is going to be completely valid example for a descending array, right? This thing varying till 0, and these are the indexes, right? So that is a very easily we can consider a particular kind of array which meets the condition that is being provided. And from that, if we were to iterate these values throughout this code, we are going to get, and basically mark down every single time swap is being called, we can get to the answer directly also. But it is going to take so much time that your gate examination is going to be finished, and even still you may not find a correct answer because you will make silly mistakes, right? So that method of completely following what the computer would do is basically stupidity, right? So if that method is not allowed, so what else can we do? Well, let's use our super ability. We humans can comprehend patterns, right? So let's follow along the fundamental patterns that are being present over here, and we're going to comprehend those patterns by taking smaller values of n, right? Smaller values of n we are going to take, and from that we are going to understand how this particular function is basically operating. Once you have very clear understanding on that, then once we have clear understanding on small amount of a small quantity, and then that quantity can be scaled into a bigger whole, that concept is known as extrapolation. And you can, with extrapolation, you can get correct predictions of enormous amounts of data, and that is the super ability that has allowed humans to do enormous amounts of things. I'm not going to count all those things. Obviously you are living in an information age, you're watching this on a computer and all, so just getting to that. So that is what I'm going to do, right? So first of all, I'm going to analyze these two for loops and the values for the variables, right, and the different variable value combination that is going to be present, right? So first this is the code from the starting containing the for loop portions, right? Over here I'm going to take n as 2, then I'm going to take n as 3, then I'm going to take n as 4, right? So these as you can see, I'm taking small values and then increasing them so that I can understand the underlying pattern that is actually being played out when this function is running, right? Obviously if you were to practice this often, you would not need all these things to be done. I'm giving this so that I'm explaining this as if you completely new to the concept, right? At least in this particular video, because it is very simple concept, so I can explain now. So over here, when n is equals to 2, your I is going to be 0, n minus 2 is 0, right? So I is varying from where to where? From 0 to 0, right? So I is varying from 0 to 0. So the only value I can take is 0. For I being 0, this part is removed. 2 minus 2 is 0. So j is also going to be 0, right? So over here, only one particular combination of values of I and j are going to be present, that is going to be hit on this if, right? So the only combination is 0, 0i and 0j, right? This is the only combination that is possible. Now if n is equals to 3, n minus 2 is going to become what? This is going to become 1. So I is going to vary from 0 to 1, right? And j is going to vary from what, right? So j is dependent upon I. So let's write I over here as 0 and 1, and the values of j that is corresponding to these are going to be written here like this. Okay, so for I being 0, j n minus 2 is 1, right? I is 0, so this whole thing becomes 1. At that point, this j is going to vary from 0 to 1, so it is going to come from 0 to 1, right? After that, when I becomes 1, at that point 3 minus 3 is going to give us 0, so j is going to vary from 0 to 0, so it is going to be 0, right? So and this bracket represents j, right? So for these particular combinations, right, this 0 and this 0, this 0 and this 0, with this 1 and this nah. So this is going to basically give us three over here, 3 entries, 0 0 0 1 and 1 0, right? So these are the 3 entries which you're going to get, right? There is no confusion. I don't think that there is going to be any confusion on this, but right, I'm not going to write this kind of expression again, but this was only to give a very good gist. This representation is good enough to represent this. It is actually even better because it is more systematic, right? For n is equals to 4, what is going to be the values, right? From the patterns that we saw till now, this kind of pattern can be extrapolated, right? So for I is going to vary till what? For 3 it varied till 0 to 1, right? 1 is what? N minus 2, right? So for n is equals to 4, I is going to vary till 4 minus 2, that is 2, 0 to 2, right? So I is going to vary from 0, 1, 2, corresponding to which j is going to vary, right? And for 0, j varied from what? It varied till the length of I only, right? 0, 1, 0, 1, similar, same. Why? Because this I becomes 0 now. At that point, this expression and this expression is exactly the same. So it is going to become 0, 1, 2. After that, in the next one, a particular value was reduced, right? So 2 is going to be dropped. And the next expression is going to become like this and then this, right? And a similar pattern is going to follow for n is equals to 5, n is equals to 6, and so on and so forth. I do hope that you're able to follow this, right? It is basic pattern comprehension. As we have generalized this, we can even comprehend in our minds what is going to be the values for the indexes. These are the indexes, right? These are the indexes fundamentally. These are the variables that are going to be used as index in the if, right? So these variables of the loop, how are they going to vary, is something we can visualize, right? From an imaginative point of view, from an extrapolatory imagination, right? We can do that. So for n is equals to 30, that is our aim. We can imagine it. We don't even need to write it, but we can comprehend slightly exactly how the pattern is going to be, right? And from computer, I basically printed out the pattern. I will give this PDF to you in the comments, so you can go through this if you want to have better visualization on this also. I do think that this is, you don't need to visualize everything, but you can get the gist. This gist has been provided up in the smaller patterns, right? It was being, this pattern was manifesting over here also. Now, once that part is very clear, so now let's analyze this if condition, right? So this if condition for this 0, 0, right? When this 0, 0 is fed into this if condition, right? So for that we actually need to need the values, right? N is equals to 2. We have to construct a imaginary array that is of size 2 and has the property of descending order values, right? So the most simplistic descending order values for size 2 is basically, as I said, taking the indexes and reversing the order, right? So 1, 0, indexes being 0, 1, right? So if this is the array that is being present and 0, 0 is the only value that is fed over here, j, see, the first value over here was for I, second was for j, and only j is used, right, here also. So we can ignore the I, focus on the j. The j is 0, right? So basically we are comparing a0 is greater than a1, right? a1 corresponds to 0, a0 corresponds to 1. With that being the condition, this condition, the 1 is greater than 0, right? So this condition is met. So this swap is going to be operated, right? There is only one combination of I and j present, right? Only one combination, one combo, right? So the number of swaps being performed is going to be less than equal to 1. Over here, as this condition was met for this particular condition, the less than equal to 1 became 1. There is for one combo of I and j, this swap was executed once, right? So let's take a function, right? Let's take the function as the number of swaps being performed. Let's take f of some x as a function that represents the number of times swaps is performed, performed, ठीक है ना, performed. Now for f of, and this n is the size of the array, right? This n is size of array. That being present, for f of 1, sorry, for f of 2, there is one number of swaps. For f of 3, the total number of combinations is basically 3, right? 0, 1 and 1, right? For this 0, these two are linked, and this one only this 0 is linked, and as I expressed over here, right? So 3 number of combos are present, right? For these 3 combos, let's see how many times this if condition is going to be met, right? And we have to take an array also, right? So let's take the array again. The array being reversing of the indexes again. So 0, 2, 1, 0, and these are the indexes, right? So now as the value 0, 0 is fed, I is irrelevant, so only j is going to be expressed, and it is going to be read in this fashion, the first row and then the second row, right? So 0 for I 0, sorry, for j 0, and j plus 1 is going to become 1, right? So these two are corresponding to these two values, right? And 2 is greater than 1, yeah, that is correct. So for 0, a swap is going to be performed. After the swap is performed, this 2 is going to get in the middle, and this 0 is present over here, right? For j is equals to 1, this aj, that is a of 1 and a of 2 is being compared, that is these two are being compared because 0 and 1 are present as indexes, right? So these two are going to be compared, right? Now is 2 greater than 0? Yes, 2 is greater than 0, so another swap is going to be performed. Very good. So another swap is performed for 1 also. Now for j is equals to 0 again for 0, we are comparing these two quantities, right? Is 1 greater than 0? Oh, yes, 1 is greater than 0, so another swap is performed, right? So for all 3 entries that were present for the all 3 combos, swaps were performed, right? So for all 3 combos, swaps have performed. So this if condition does not really restrict us over here. Why it does not restrict us is something I am going to explain to you, but I do hope that you can observe that this if condition has not been restricting us for f2 also, and now for f3, as for 3 combos, 3 number of swaps are performed. So this is giving f3 is equals to 3, right? So now let's go for the fourth the n is equals to 4 also, because this is a pattern observation that we are doing, so that there is no confusion whatsoever. I'm going to do for n is equals to 4 also, right? I is varying from 1 till 2. Why? Because 4 minus 2 as is done over here is going to give us 2. So I is varying from 0 to 2, right? Now this part I have already explained, right? So now for now let's take the array. The array being equal to reversing of the indexes, right? So 3, 2, 1, 0, 0, 1, 2, 3, right? So, and this is your array. So for, wait a minute. So for j equal to 0, we are comparing the first 2 elements, and 3 is greater than 2. And this is happening, right, because it was a descending order operation, right? The array was given as descending order. Every single combination comparison of j to j plus 1 is going to yield to true, because that is the definition of descending order, right? The values are decreasing in this fashion, right? The values are decreasing in this fashion, and we're comparing 2 quantities, and that as increasing indexes are present, right, j plus 1 is increasing the index, so the quantities are reducing, and hence this if condition is always meeting with a true. That is the funda that is happening. Because it was descending order, it is coming to true for 0 also, and for this 0, this swap was performed, right? as this swap was performed and the biggest quantity in the array has gone to the index 1, and we're comparing index 1 to index 2 by this operation, we get 3 being greater than 1 one more time. So it is also going to get swapped, right? For 2 also, because 3 is the greatest quantity in the whole of the array, it is also again going to get swapped. Now let me explain to you this concept, because now as this j was varying from n minus I minus 2, so because I was reduced, this portion was never considered. J did not get to here because j did not have a value 2, so this 0 was never compared to 3 again, right? This is very important because this thing effectively removes this part of the array from further considerations inside of this if conditions, right? And because this greatest quantity in the array was removed from the consideration, these 3 elements are again in descending order. So the behavior which we got for 3 is also mirrored for these 3 elements. 2 is the greatest element in this sub array, and it is going to invoke again it is going to always invoke this if condition with true value, right? And that thing is going to lead to swaps. This thing corresponds to this 0, and then for this one, this 2 is going to again get swapped with 0, right? Very good. As you can see, at the end of the second row that was completed, the greatest 2 elements are to the right side, right? And now for the last row, only 1 is compared to 0 and 1 is greater than 0 because this subarray is again in descending order. So for this also another swap is performed, and for this swap, as this swap was performed, your quantity became 0 1, right? Like this, the whole thing became sorted, right? We started with what? We started with 3 2 1 0, right? And we got to a sorted answer, right? So already I know that we started with a descending order sorted array. We started with a descending order sorted array, and we got to a ascending order sorted array, right? So this particular whatever code this, it is basically representing what? Bubble sort. And this bubble sort was being expressed to us, right? This was the code. Somebody who has already studied bubble sort, has revised bubble sort, would have directly identified that yes, bubble sort is being performed, right? But obviously, as it is a gate question, a bit of complexity was introduced, and that complexity was in the fashion that how many number of swaps is going to be performed, right? And because it was descending order and everything, we got what? For F4, right? For F4, we got till what? So these 3 number of every single element in this particular matrix that holds the values that j is going to take, right? In the order is also fixed, but the quantities that j is going to take is being resulting to a swap, right? This row contains 1, this row contains 2, this row contains 3, right? So the total number of swap is going to be what? 1 plus 2 plus 3, right? And what is this thing, right? This thing is going to give us 3 times 4 by 2, that is 6. I'm basically invoking this formula, n plus 1 by 2 gives us your summation of 1 plus 2 plus till n. I'm invoking this formula to find this, right? As you can observe, this kind of pattern was present over here also. We added 1 plus 2 and got our answer as 3, right? So this pattern can be extrapolated through the values, and we can directly apply for fn, right? For fn basically being equal to 30, we can get the value, but for that we have to generalize this function. We cannot skip that step because it is going to lead to a silly mistake, right? Because of all of this pattern recognition, we got to what? We got till the fact that f of n is basically equals to 1 plus 2 plus till n minus 1. This n minus 1 is very important. See, for 4 it added till 1, it added till 3. For 3 it added till what? 1 plus 2, it added till 2, right? So for n it is going to add till n minus 1, and if we feed n minus 1 into our formula of n plus 1, what is that going to give us? It is going to give us n minus 1 times n by 2. That is your answer, right? Put in the value of 30 into this, you're going to get directly going to get your answer. I'm going to do this in the first page, right over here. F of n is equals to n minus 1 times n by 2. F of 30 is going to give us 29 times 30 by 2. This is going to give us 15 times 29, right? In GATE you're going to be given calculator, so you can do that from there. I can also open calculator on this computer, but I can directly multiply, and it's not a very big multiplication, right? So 45, and this is 1, and this is 9 2, right? That is 5 3 4 435 is your answer. So for this the answer is 435, right? And it was a good question. I would say it was a good question. I will provide the PDF for this. You can go through all of this one more time. You can go through the video if you don't understand it, because I do think I explained it good enough, right? And this is something I printed so that for your convenience, right? So you can comprehend the extent of your pattern recognizing usage, right? If you use pattern recognition, if you recognize patterns and then extrapolate from that, you basically skipped through the analysis of all of these indexes, right? This is for, these are the values of j, right? These are the values of j that you must take into consideration when you're calculating F30, right? And these are the values of I, right? For values of I being varying, j, these values of j are present, right? If you add up all these, right, from 0 till 28, right? So this particular row contains how many values of j? Because 0 is also included, it contains 29 values of a, 29 values of j, right? And like that, and so on and so forth, right? And with that, I will see you in the next video. Thank you.